So, problem number 3 on the notes. You have a parabola, and it tells you some information. It gives you the vertex, and it gives you a point that it's passing through. So if you're a parabola, what 2 equations could it look like? Well, we could have x squared equals 4py, and by the way, 4 could be positive or negative, right? If it's x squared, it's like that, or like that, right? If it's y squared equals plus or minus 4px, what do these 2 look like? These are on its side. They're either shaped like that or that. It's a positive 4 if it's that way, negative 4 if it's that way. Well, let's see what we have. We have a vertex of negative 4, negative 3. So we're going to go 1, 2, 3, 4, 1, 2, 3. That's our vertex. And it tells us that it's passing through 4, negative 5. So 1, 2, 3, 4, 1, 2, 3, 4, 5. Well, if this is our vertex and it's passing through this point, what does it look like?
Looks like that one.
It's shaped, it's on its side. It also gives you, we have an axis of y equals negative 3. Axis means axis of symmetry, not directrix. So if that's our axis of symmetry, you should know automatically that you have another point that is 2 units away from the axis of symmetry. Okay? So what does our graph look like? It looks like that. So if we're going to write all that we need to know on this parabola, I want to know the directrix, I want to know the focus, I want to know the latus rectum endpoints, I want to know everything. I want to know the equation. So starting with this picture, which equation am I going to attack? This one or this one?
What?
That one. So now I want this one for sure. If it were up and down, I would do the x squared, but it's not. I want that. Now the first thing you're going to want to put in is the vertex. How do you insert this vertex into this equation? What goes where? We have a negative 4 and we have a negative 3. Go ahead, Chris, what did you say? X gets the what?
Negative 4.
Yep. And y gets the negative 3. So, how am I going to put this in? I'm going to go y plus 3 quantity squared equals 4 times some p-value x plus 4. Does everybody agree that that's the center right there? 4, negative 3. Now, what am I missing? What am I missing?
P-value.
The p-value. That p-value gives us a lot of information. It tells us our fixed point. How many units is that p, is that unit away from the vertex? And that p-value also reappears by the directrix. It's that many units away from the vertex. So how can we use the information? We have a point that it passes through. How can we find p? If we know a point that it passes through, we know the vertex. What can we do with this? This is the only piece of information we haven't used yet. What do you think you could do in relation to this equation and this point that's given? So we can find p. We do it a lot in math.
Plug.
Yep, we're going to plug 4 in where? For x. And we're going to plug negative 5 in for y. So let's do that. Negative 5 plus 3 quantity squared equals 4 times some p-value, and x is 4 according to this, 4 plus 4. Now let's do the math. Negative 2 squared is 4. Now this says 4p and then 8. What does 4p8 mean? What does 4p8 mean? Anyone? 4p8. What is it?
32p.
32p. How do you solve for p? And what do you get? 4 over 32 is another name for 1/8. So where does the 1/8 go? It goes in a lot of places. 1/8 can be put right there. Now, it's not 4 and an 1/8, it's 4 times 1/8. Or actually, I should put it right there, or right here. So you're gonna write y plus 3, the equation would be y plus 3 squared equals 4 times 1/8 times x plus 4. That's your equation. Sorry, it's squished in there. So again, I'm gonna write it better. Y plus 3 squared equals 4 times 1/8 times x plus 4. Can I simplify this? Absolutely. I can write y plus 3 squared equals, how can I simplify this? What's 4 times 1/8? 1/2. And actually, you could even do more to this equation, just what you wanted. What could I do to this equation? I could solve it for x. If I wanted to solve this for x, what's the first thing that goes?
Y.
The what?
Y.
The 2. We have to multiply both sides by 2. To attack this x, first get rid of this. So you'd multiply this by 2, this by 2. Okay, and then how would I get x by itself now? How do I get rid of this 4? Subtract 4. Whoops, minus 4. So I just want to show you that this equation is the same as this one, it's just rewritten. Okay, so we found out that P is 1/8. Could you give me the coordinates of your fixed point? So this is what we have. We have this graph like this. This vertex is -4, -3. So if P is 1/8, could you give me the coordinates of that fixed point? -3 and 7/8, comma, -3. That would be your foci. That would be this ordered pair. Could you give me the equation of the directrix? You would go 1/8 the other way. How would you write the equation of the directrix? X equals -4 and 1/8. It's a line. And one more thing, if I wanted to know these endpoints, this is your latus rectum. Your latus rectum is 4 p units long. Well, if p is 1/8, our latus rectum measures 1/2 unit long, which means that's a quarter and that's a quarter. So if I want to take this whole 1/2 and break it up into 2 parts, half of a half is 1/4. So from this point's name is -3, 7/8, -3. How would you go up 4 and down 4 and name these coordinates? This coordinate and this coordinate would be called -3 and 7/8, comma, -3, and you can write plus or minus 1/4. That would give you these 2 ordered pairs right there. And I'm fine with you writing it just like this. If you wanted to simplify it, go for it. If you want to leave it like that, I'm okay. That shows me that you know exactly where your 2 endpoints are. Do you guys understand this? Okay, next one, number 4. I have a conic section that's written in general form. I have no idea what it is. So what's my first step? I have to get it into standard form. To get it into standard form, why would I want it in standard form? Why, what's so special about standard form? You can find everything. With a little bit of knowledge, you can find anything. So, what's wrong with this problem right now? Where should we first attack this? We have 4x squared plus 25y squared plus 32x minus 50y minus 11. It's all jumbled up, so what do I want to do? Step one,
Get the x's and y's.
get the x's and y's together. Let's start with x squared. So 4x squared plus 32x plus something, and then let's attack the y's. Now, I always bring my constant to the other side. Why did I put 2 blanks on the left side? What do I need to, what's that thing that we have to do?
Perfect
This
square.
side.
We have to complete the square.
Shouldn't it be -50?
-50, yes, thank you. This should be -50. Thanks, Chris. Okay. What has to be taken out of these two before any completing of the square can be done? What needs to be taken out? That 4. You have to pull the 4 out because to complete the square, the leading coefficient has to be 1. We always learn that, right? Okay, now stop right there. How do you complete the square? What do you do?
Take half of this without even
Half of 8 is, in square, what do you get?
60.
16.
And it-
Now, is it okay if I just drop a 16 right here and walk away?
Other side.
I have to drop a 16 here, not a 16, but I need 4 16s. I need 4 of them, which is 64. So I'm gonna add 64 here. And I have to do the same process here. I'm gonna pull 25 out. You have y squared minus 2y plus something. Half of 2 is 1 squared is 1. I'm gonna add what to the other side? 25. Sorry I put it up here because I'm running into my graph. All right, so now let's factor this completely. How does this trinomial factor right here? What does it look like when it's factored? Anyone? What's x squared plus 8x plus 16? How does this factor? Factor it. Hi, guys. How does this
Plus
factor?
4.
X plus 4 quantity squared. Okay, now how about the y squared minus 2y plus 1? How does this factor?
Y minus 1 square.
And then add these up, you get 100. Okay, now what do? You had something similar to this on your last test.
You divide everything by 100.
100. The 100 is the boss here. Get rid of this. You need a 1. You need a 1. So you end up with, what's 100 divided by 4? It is 25. 100 divided by 25 is 4 equals 1. What is this? It's an ellipse where the center is what? -4, 1. And it's elongated on the major axis is the x-axis. You're going to go 5 each way, east and west. 1, 2, 3, 4, 5. So these are your coordinates of your major axes. Your minor axis is 2 and 2, which ends up being 4. And if you connect your dots into an oval-shaped ellipse, there it is. Would you from here be able to name the coordinates of the fixed point? Sure. What's the relationship between a squared and b squared?
A squared minus.
It's a squared minus b squared. So you would do 25 minus 4, that's your c squared. So c is going to be the square root of 21, plus or minus. So what you have to do is you have to start with your center, which is -4, comma 1. you have to add and subtract root 21 from which of these two? Which of these two? From the x value here. So your fixed point would be negative 4 plus or minus the square root of 21, comma, 1. These are your coordinates of your fixed point. It is, you start at negative 4, and you're going to go root, you're going to add and subtract the square root of 21 from this point. So these are the coordinates of your fixed point. If I wanted to know something about the lattice rectum, do you remember what the lattice rectum is on this? It's 2b squared over a. Use this, use these as your a and your b squared, and then you plug that in and you can find out how high and how low you're going to go from your fixed point. So out of these two, which is the b squared value? This is going to be the a squared, and that's going to be the b squared. The smaller is the b squared. So it would be 2 times 4 over the a value is 5. So 8/5 is your lattice rectum. That's how long that chord is. So if you cut that in half, if you cut this in half, you end up with 4/5. So you would add and subtract 4/5 from this point. So if I wanted the 4 lattice rectum points, I'm going to add and subtract 4/5 from this y value from each of these, and that will give you your coordinates. Okay? What if I asked you what's the area of this? I'm just reviewing completely. Area is pi AB. So it'd be pi times 5 times 2, which is pi times 5 times 2, or 10 pi. Area is 10 pi units squared. Last problem, and I have a typo here. It's 2 units up, and I want you to do 4 units left. Okay, so I have some conic here. It looks like it's going to be a hyperbola because of the minus. So what you're going to do is, again, same as you did up here. You've got to collect your terms. You've got 4x squared minus 24x plus something, whoops, minus y squared plus 6y plus something equals negative 11. Again, you have to pull the 4 out. And here you have to pull out a negative 1. That's a little tricky here. Okay, so half of 6 is 3 squared, you get 9. You're adding 36 here. Half of this squared, again, is 9. This is negative 9, so you have to add negative 9 to the other side. Whatever you do to one side, you do to the other. Factor. And when you add these up, I believe you get 16. Negative 11 and negative 9 is negative 20, plus 36 is 16. Now what do? Get rid of 16, so I'm going to divide everything by 16. So you get x minus 3 squared over 4 minus y minus 3 squared over 16 equals 1. So what does this thing look like? It's a hyperbola, where the center is what? Where's the center? It's at 3, 3. It's on its side because x goes first. A is 2. You're going to go 2 units this way and 2 units that way. So it's looking like this. So this is your transverse axis from vertex to vertex. Your conjugate axis, it says b squared is 16, so b is gonna be what? 4. You're gonna go 4 units this way and 4 units this way. So if you were asked to sketch this graph, here's your asymptotes, and so your graph would really look like that. If I wanted to find the asymptotes, this is what you're going to do. It's y minus k plus or minus, it's a b to a ratio, like that. So where is my center? It's 3, 3, right? 3, 3? 3, 3. So you'd put a 3 here and a 3 here. And I need my b to a ratio, so it would be a 4 to 2 ratio, or 2. Just keep it as 4 over 2 for now. And what you could do is you could simplify this some more. You can write plus or minus 2, and then distribute. So there's 2 actual equations here. So this would be 2. So if you did 2 times x minus 3, or negative 2 times x minus 3, and then distribute. So 2x minus 6, and add 3. So if you added 3 here, you'd get 2x minus 3. So one of your asymptotes is that equation, and then negative 2x plus 6, add 3, and that would be the other asymptote. Now, for this question though, they wanted you to take this graph and move it 2 units up and 4 units left. So if our hyperbola, our vertex is at, or our center, not vertex, if our center is 3, 3, and I wanted to move this whole thing 2 units up and 4 units to the left, I am taking this point, 3, 3. If I shift it 2 units up and 4 units to the left, this is my new center. What ordered pair is that? If I went up 2, it's going to bounce this up to 5. And if I move this 4 units left, it's going to move this x value to negative 1. So my new vertex, or my new center, I keep saying vertex, my new center is negative 1, 5. My new center is negative 1 because I shifted it 4 units to the left and up 2 from this spot. So could you give me the new equation translating this 2 units up and 4 units left? Absolutely. All you'd have to do is change these 2 numbers right here. These will stay exactly the same. So the a and the b value are not going to change. So it's going to be y plus 1 quantity squared over 4 minus y minus 5 quantity squared over 16 equals 1. So you should be able to take any equation and translate it. All you have to do is change the center or the vertex, whatever you're dealing with. That's it. Everything, the a and the b stay the same. Okay, that concludes the notes.